Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the YouTube channel Chandan Physics. In this video, we are going to discuss classical theory of electronic polarizability. Let's begin. What is electronic polarizability? The electric polarization occurs due to the displacement of positive and negative charges in a dielectric material. When the dielectric material is present in an external electric field, or in other words we can say when an external electric field is applied. Let me consider an atom of dielectric material. The nucleus of the atom has positively charged, and that one is the tiny portion of that atom, and all the masses are concentrated at that of small region which is known as the nucleus, and it is positively charged. Around that of nucleus there will be such kind of electron clouds. These electrons revolve around that of nucleus in their specific orbitals. But when no such an external electric field is applied, we see that kind of charge distribution. This is the charge distribution in absence of electric field. But when we apply an external electric field, then what will be happened to that of charge distribution in the atom of that particular dielectric? Which is the atom when we apply an external electric field. Let the direction of external electric field like this, that is the external electric field. Therefore, the direction of positive charge is same as the direction of external electric field, and the negative charges, the direction of negative charges is just opposite to that of direction of external electric field. Therefore, positive charge shifted to this position, that is along the direction of electric field, and the negative charges are distributed like this. This is the charge distribution when external field is applied. External electric field is applied. In that case, when there will be no such external electric field, or we can say that is in the absence of external electric field, that positive charge on that of nucleus and the negative charges around that of nucleus both are attracted to each other by the Coulombic force. Therefore, that atom overall we say is non-polar. But in that of case, due to the presence of external electric field, there will be such kind of arrangement in that of charge distribution, and now that atom becomes polar, and that process is known as polarization, and that kind of polarization is termed as electronic polarization. Therefore, we can say every atom in a crystal has electronic polarizability. And in each atom that kind of phenomenon occurred. Every atom in that of crystal has electronic polarizability. Let we have to calculate mathematically the electronic polarizability by using classical theory. In order to find the expression for electronic polarizability, we can predict that the restoring force on the electron cloud when these electrons are displaced from normal configuration about the nucleus. And which one is proportional to the displacement. So, that restoring force on electron cloud when these electrons are displaced from that of normal configuration about that nucleus, the electrons are displaced, and that displacement which is proportional to that of displacement, that restoring force is proportional to that of displacement. Guess it, restoring force proportional to displacement, that kind of similarity we observe when we are dealing with harmonic oscillator. In case of harmonic oscillator, restoring force is proportional to that of displacement. Let we can imagine that system into a harmonic oscillator. Thus, the system can be approximated with a harmonic oscillator. since the restoring force on that of electron cloud is proportional to that of displacement, therefore it is very similar to that of harmonic oscillator. That is why we can easily relate the system to a harmonic oscillator. As a result, that equation of motion of an electron that is bound harmonically to an atom in an oscillating field. And that oscillating field, that is E into E to the power I omega t. That is the equation of motion m d2x d2 dt square plus m gamma dx by dt plus m omega naught square x is equal to E into E to the power I omega t. Equation number 1, where small m, that is the mass of an electron, and E, that is the charge of electron, capital E, applied external electric field, omega naught, that is the natural frequency at which that electron oscillates, natural frequency of oscillation of electrons, natural frequency at which electron oscillates, and omega, the frequency of applied field, that is the frequency of applied field. A constant is used here, gamma. Here gamma, that relates towards the damping effects. It includes damping effect. And that gamma, we can relate it towards the natural frequency, and it is equal to mu naught E square omega square divided by 6 pi mc, where we know c, that is the velocity of light, mu naught the permeability, sorry, that is the permeability. We have to know all these things. Therefore, the solution of such kind of differential equation as x is equal to x naught e to the power I omega t. Then obviously its first order differentiation dx by dt is equal to I omega x naught e to the power I omega t, which is equal to I omega in that term x naught e to the power I omega t is equal to x, and its second order differentiation d2x dt2 is equal to minus omega square x naught e to the power I omega t, I square, that is minus 1, so it will be minus 1 omega square x naught e to the power I omega t, which is equal to minus omega square in that term written as x. X dx by dt d2x by dt square, all these values now put it in equation number 1. Putting these values in equation 1, we get m d square x by dt square as minus m omega square x plus m omega dx by dt, the value of dx by dt is put I m gamma omega x plus m omega naught square x, the value of x is put, it is m omega naught square x is equal to e to the power I omega t. Taking common mx inside that bracket minus omega square plus I omega into gamma plus omega naught square, which is equal to e into e to the power I omega t. Or x is equal to e by m e to the power I omega t divided by your omega naught square minus omega square plus I omega into gamma equation number 2. As the electronic polarizability is given as alpha I, electronic polarizability, which one is equal to E x divided by e to the power I omega t, the electronic polarizability. Now the value of x is put here. Therefore alpha E is equal to value of x as E by M something. So E into E square, here E cancelled out. In the term numerator we have M omega naught square minus omega square plus I omega gamma. Equation number 3. And this one, this is the required expression of electric polarizability. Expression for electric polarizability. Again, we can write that electric polarizability in the another way. The complex dielectric okay, that will be the final expression. No such additional information we have to analyze, because as far as your syllabus is concerned, we just evaluate on that thing, that is electric polarizability. So here, with the help of this video lecture, we understand the concept of classical theory of electronic polarizability. First we define what is electronic polarizability, what exactly happened when there will be no such an external electric field, what happened when an external electric field is applied. Accordingly, the concept of electronic polarizability is established. Next, mathematically, we derive the expression for electronic polarizability by using classical theory. To treating that classical theory, first of all, we relate it how the restoring force on that of electron cloud is directly proportional to that of displacement. On that way, we assume which one is approximated to harmonic oscillator, and then the equation of motion of harmonic oscillator is used, and its solution, first order differentiation, second order differentiation, and these values are put in that of equation of motion. Then finally, the expression for electronic polarizability by using classical theory is evaluated. So, with this useful uninformative notes, let me wind up this session. Thank you.